So my name is Vishal. I'm the founder and CTO at InfraCloud Technologies. We are basically a programmable infrastructure company. We help people adopt infrastructure, modern infrastructure platforms, and move and use them more efficiently. We are the first Kubernetes partner in India and second in Asia Pacific, and we are also a Rancher partner. Rancher provides Kubernetes, Mesos, and Swarm as a service through its platform, basically. You can connect with me on LinkedIn or Twitter or wherever. So I think in 1990s or maybe early 2000s, we started with hardware-less, like no hardware, right? Let's use cloud, let's use virtual machines and things like that, right? Then at some point, containers came into picture, like 2010-ish, and we said no more VMs, let's just use containers, right? And today we are saying no more containers, let's just use servers, like functions, so no servers, serverless, right? Maybe a few years down the lane, we'll have a conference called functionless, nothing, just throw variables at runtime and things will work fine. That was a joke from the Twitter conversation between Kelsey and Christopher. But jokes apart, let's get to some serious stuff, right? So I'm talking about, so it's not table of content, it's table of functions, if you have noticed. So first of all, why Kubernetes for functions? Why not something else, right? Why not Docker Swarm? Why not Mesos? Why not something else? Secondly, motivation behind Fission. A lot of people ask, why do we need serverless on-premise when we have Lambda, when we have Azure functions, right? How do you save cost? So we really need to understand the use case for that. And what are we trying to achieve? Are we trying to just do it for the sake of doing it because AWS is doing it? No, there are reasons we are doing it, right? Then we'll talk a bit about Fission concepts, architectures, and a little bit of features. And then finally, demo. Hopefully, demo gods, be in favor of me today. And then we can look at open questions in general, right? So why Kubernetes? So first of all, not everything in the computing workload today is a function. You can't say I'll use database as a function, right? Definitely not. You want database to be up and running 24/7, or message queues, right? They can't be down and up as you need or as you need on demand. They have to be up and running 24/7. Then in Kubernetes, you get a lot of abstractions built in. For example, you get logging built in, you get container abstractions like stateful sets or containers or pods built in, right? So you don't have to reinvent the wheel. So your common and cross-cutting concerns are taken care of, and you build based on that, basically. Thirdly, Kubernetes is very, very extensible. I don't know how many of you are aware of the third-party resources or custom resources. So basically, Kubernetes by default provides abstractions like pod, stateful set, job, daemon set, and things like that, right? But there might be a business case in your organization where you need something completely different. So you can write your own abstraction, and it'll be defined in the API the moment you define it in the Kubernetes system, and then you can use that as your abstraction, right? So it gives you a very good way to extend your business's use case beyond the standard abstractions that are built into it, right? And lastly, I believe Kubernetes is a platform which is gonna make the eventual reality of being multi-cloud or cloud neutral a possibility, in practice. We probably have given a lot of shots at that as an industry, maybe with OpenStack, CloudStack, and other things. But I really believe strongly Kubernetes is that platform which will make us cloud neutral or multi-cloud operable. Now, why serverless, right? If you're saying, like, I have my data center, my machines are running, and no matter what, I'm going to pay for the machine's electricity and the cooling cost, so my cost is anyways fixed, right? Why use serverless and why use functions? So in general, operating Kubernetes is fairly complex. It is getting easier day by day, but it is still not the most efficient or simple experience for a developer. You need to understand a lot of concepts. You need to understand the whole end-to-end flow and things like that, right? So what we want to do with serverless is hide this complexity from the developer. For developer, it should be as simple as I give my code, and I deploy. I don't care how things happen in the background, right? So we want to provide that level of abstraction between the developer and the platform. Secondly, optimize resources. Now, somebody had asked a question in the previous session, I believe, right? What if my VMs are running all the time? How am I saving cost by running serverless functions, right? Let me tell you this way, right? So if you have VMs anyways running, you can still optimize the number of VMs that you're running. But within those VMs, how much you're optimized? Are you optimized for 80% efficiency of your infrastructure or 100% efficiency of your infrastructure? For example, a Google developer sometime told me that when they run a BigQuery query from an end user, they don't run it on a single machine. They basically split that into thousands of small tasks, and those small tasks run on thousands of different machines. So the machine might be like 80% full, and 20% might be still idle, and those 20% can be still utilized by splitting these small tasks into X number of machines, right? So we are talking about that level of efficiency where our infrastructure is highly efficient and highly optimized, and eventually that will save cost in terms of reducing the overall number of VMs, right? So that is the optimization of resources. Secondly, cluster capacity as a function of actual usage. Now let me tell you this, right? When you, let's say, buy something on a Cleartrip or any other portal of airlines, right? You buy the ticket, and then you get an email like an hour later or 2 minutes later or sometime later, right? These kind of jobs don't have to happen even immediately, right? So these kind of functions can be put into a function instead of putting into systems which are running 24/7. So anything that doesn't need to be responded immediately doesn't have to be running 24/7. That way, it is not like my server is running 24/7, but it is only effectively active for 1 hour in that 24 hours, right? I want to do it this way, that whenever I need something, I get that job done, and then kill that execution environment, and then free up that resource to be used by somebody else. So that's what we are talking about here. Now, let's talk about a little bit of Fission terminology. So in Fission, there is concept of, at a very broad level, these are the 3 concepts, basically. So there is function. Function is what your execution code or logic is, basically. It can be any language. At the moment, I believe there are 8 runtimes supported: Node, Go, Java. There is also C, Ruby, and a couple more. So that's your execution logic. Then there is environment. Now, environment is different from your actual code. Environment is the bare platform which will host your code. For example, if you have a Node.js code or JavaScript code, basically, you will have a number of libraries, and all those things are baked into an environment. You can use standard environments, or you can build your own custom environments based on your needs. And then at runtime, it basically applies the code to the environment and executes the function. And that's where somebody had a question about the latency. Like, can it support 10 milliseconds or 20 milliseconds or 100 millisecond kind of latency? Fission does that. I'll show you in a bit how it does that, right? Then there is route or trigger. So trigger is the thing which is going to invoke your function. In certain cases, it can be a HTTP GET request. In certain cases, it can be a timer. For example, I want something to be happening every day night at 11 o'clock, right? So timer is the trigger in that case. In other cases, it can be a message queue. So if somebody logs into some website and does some operation which can be done offline, you can probably drop that message into a queue, and eventually it will be picked up from the queue and executed offline, right? So those are the 3 broad triggers supported today. But there is also plans to build new kind of triggers and extend existing triggers as well. So one interesting integration that is available today is the integration with NATS. So NATS is a message-based platform which is also part of CNCF, I believe, and it integrates with NATS pretty well. Now let's look at a little bit under the hood. What's happening? What Fission is doing? Under the hood, right? So you have the API endpoint, which is basically listening and active at all points in time, and those colors represent different kind of functions that you have, right? So first of all, you define your function, and the moment you define your function, pool manager is a component which is notified. And what pool manager does is that, so let's say you're defining a function for Node.js environment, it will pre-create Node.js environment pods and keep them ready. There is no actual execution logic, it is just the environment, base environment, right? When the actual requests come in from the user, it goes to the router, and the router talks to pool manager and say, hey, I have a function execution requirement right now. Can you give me a pod? So it takes out one pod from that pool, puts it into a separate bucket. It's called specialization, basically. Now, that pool will still remain the same. If it was pool of 3 or pool of 10 or pool of 1,000, that pool quantity will still remain the same. You take out one pod just for this function execution. And then the code is put into that environment on the fly. Now, the guarantee is that no matter what the environment is, we will support 100 millisecond latency. The latency won't be more than 100 milliseconds. And that is achieved using maintaining a pre-warmed pods with environment and functions being dropped on the fly. Now, once this pod is specialized, it is ready for serving the traffic. And that's when the traffic is routed to that ready pod, and the responses are sent back. Now, once this execution is over, it waits for a few minutes. If more requests are coming in, it can be served by one of these ready pods, which are already ready. So if you, again, if I'm able to show this in demo, I'll show, of course, but the first execution is typically 100 milliseconds, sometimes less also. But the second execution onwards, it's much shorter. because the warm pod also has been specialized and it is ready to serve traffic. So it stays alive for a few minutes. Then it sees there is no request coming in, then it will kill these specialized pods and still keep the generic pods as it is, right? So that's the way it handles on-the-fly and low latency requirements, basically. There are additional features in Fission. So I talked about event queues, right? So it has a support to integrate with nats.io. Nats.io is a very highly scalable and a CNCF supported platform. So what you can do is any Fission can be triggered by a message being dropped into a queue, and then it can drop the response into another queue, right? And this can be made into a pretty complex workflow. Like you can have different message queues and different functions, and then you can stitch them together to create a pretty complex workflow. The same is possible using a feature called workflow in Fission. So there is a separate project called Fission-workflows, which allows you to, again, like have a complex pipeline of functions. So input to a function can be output of the previous function execution. So that way you can have a handshake between the functions. And it also supports like fan-in, fan-out. In the sense, I can have one execution or one function being called, and then it branches into two separate execution flows. And then it joins again. So when it joins, it waits for the previous two to finish, basically. For example, in this case, the C and D both will finish, only then E will be executed. So those kind of complex workflows you can create using Fission workflows. It also has built-in support for monitoring and logging. For example, there is already InfluxDB and Grafana deployed. So you can get all the log data of all the functions that are deployed. Some amount of basic monitoring is also provided. And some of the features are probably still work in progress. For example, Fission UI is work in progress. There is auto-scaling that is being built in, and those kind of features, right? So let's go to demo. But as I said, there are some bugs ahead, because we are still working on the latest and the greatest version out here. And hopefully my browser is, so I never used IE in last few years, so I'm going to struggle a bit here. Please bear with me. I can't see the console. Control F. All right, go to console. Cool. So what I've done before coming to this demo, or to this session today, is I have already created a Kubernetes cluster on Google Cloud. I could have as well done it anywhere else, but I have just chosen for sake of simplicity. And I have also deployed Fission on top of that. Yeah, so my server is already running. It has 4 nodes. I'm going to create a console so that I can show you things. So okay, so let's list all the functions that are currently deployed. Okay, Fission not found. That's interesting. I did install it before I came here, but let me install it once more quickly. Sorry? I did move it to path as well. Most likely, I moved it to user local bin, which gets wiped out in Google Cloud Shell after every re-login. And most likely, that's what has happened. Let's see. Oops. Right, for some reason, this drop-down menu is not opening here. Okay, let me go and grab from GitHub project directly. So Fission is a completely open source project. There is no strings attached in terms of any commercial obligation. and it is written in Golang. It is right now at 0.3. We will probably have a beta early next year, and GA will be, I don't know the exact dates, but it will be after that somewhere. All right. So let me go to releases and grab one of the binaries. So Fission CLI Linux, I can copy that. Open a new tab. The mouse just freezes up. All right, cool. So Fission has a CLI. That is the primary way you can interact with more or less today. It also has an API, so you can integrate with any of the other systems that you can hit with REST API endpoint, basically. And Fission Workflow is a separate project at the moment, but it's just another what I can say, binary or a pod that runs into the same cluster. Let me open one more console so I can also show you the current runtime environment, what it looks like using kubectl commands. Oops, typo. Yep, thank you. This is what happens when you jump on a new machine and you are supposed to demo. All right, that's a bit slow. Yep. Cool. So you can see there is Builder Manager. So they recently also added a feature that you just provide the code and also build happens on the fly. For example, languages like Java, where you need to do compilation. You don't want to build binaries and then give it to Fission. You can say, just give source code and you figure out how to build it. Similar to what build packs in Cloud Foundry is, more or less. InfluxDB is, of course, for logging all the data. There is KubeWatcher. So KubeWatcher is basically used for watching any Kubernetes events. For example, I want to say, hey, anytime the number of pods for billing application go beyond 10, please inform me. That's not something right? So those kind of things you can do. And there is, of course, limitless things that you can do around it, right? There is Logger, which basically logs, as you can notice from the name. There is MQTrigger for message queue-based triggers. There is NATS. Pool Manager is the core component which manages the pools of each environment. And then there is Router, which routes. Storage service is used for any functions whose code is larger than 256 kilobytes. So typically, of course, you are assuming that your code will be small for a function, right? Because function is supposed to be small. If you're putting your whole microservice into function, of course, nobody can help. So that service is used to store that data somewhere else. And there is Timer for timer-based triggers, and there is Workflow for workflow engine. Right. Hopefully, our CLI is downloaded already. So let's go there. Oh, it's in the same window, but in a different tab. Okay. So I'll first do a chmod. And sorry about the slowness in the demo, but we have time, thankfully. I'll just move it to use the local bin, so I don't have to call it every time. I'll do sudo. I wonder. Right? Cool. We are up again. What happened now? Okay, I shouldn't have moved it to, or just let me copy back. Sorry? Oh, yeah, sure. You know what? I'll just move it to my directory back. Of course, again, sudo. Oh, you know what? Yeah, there is a directory here. Oops, that's taking a bit of time. So there is a Fission directory that I have checked out in the same directory. That's why the conflict, I guess. So I'll run out once more.
So every time there is a new release of Kubernetes, the Fission library has to be changed.
No, there is no dependency at the moment in terms of Kubernetes version, except for in the latest release, which is 1.7 to 1.8. The Kubernetes changed the name of third-party resources to custom resources. So now we have to rebuild and release a new version. But other than that, there is no like tight dependency between So while this download happens, any questions from the folks? Sure. Fission only works on Kubernetes.
So before you want to develop some serverless stuff, then we use Kubernetes.
Correct. On Kubernetes, yes. Yeah, just a minute. I'll just. So autoscaling is a feature which is not yet ready. It is being built. The basic ways, of course, is you measure the matrices like CPU or a RAM of a certain function. And if you notice that it is going beyond certain threshold, or so there has to be some metric that tells you that this function is overloaded. And then that metric ties into Kubernetes eventually. So you just provide the metric to the autoscaling part, and then it'll figure out how to scale it.
We are trying something on native Kubernetes using custom API, just running, creating custom metrics
Uh-huh.
from HTTP request and export that to HPA.
Sure.
According to that.
Sure.
So is it the same way handled?
Yeah, so we have been thinking about like horizontal pod autoscaler, and I think in the latest release there is also something called as vertical autoscaler, right? So we have been thinking about multiple approaches, but as I said, it is not a feature that is ready yet, and we might have all, or we might have some based on what fits the project's overall architecture the best. Okay. So, all right. Okay. So I have to configure my server environment variables. So to point to Kubernetes, basically, oh wow, the select doesn't work here. That's pretty strange. Whew. Come on. Okay, I'm just I'm gonna copy from the. So the environments are listed here. There is an environment called binary as well, which is basically you can put any binary which is executable, and then that's the environment. Doesn't matter what language, all that stuff. There is Go, there is .NET 2.0 as well, Node.js for Alpine, Debian both, Perl, PHP 7, Python 3, and Ruby. And deploying it is simple. Like you can use Helm chart. It has a Helm chart built in, and that's it. It deploys to the cluster. What is it copying? I have no idea. Let me just give it one more shot. So in the worst case, this demo doesn't work out. What we can do is I can show it on my own laptop. That will be probably far easier. But hopefully it still works here so that everybody can see it. My screen is not big enough that everybody can see it. Cool. Okay, great. Finally, we are there. So these are the existing functions that I have deployed. But what I also want to do is I want to show you guys right now here, create a function. First of all, create an environment, then create a function, then create a route, and hit it, and at least see a hello world, right? That's the basic minimum we want to see. I'm not positive if we can do workflows demo, given the amount of time that we have and given the technical challenges I have with the demo things here. Okay, so my code, which I'm going to deploy, is this. It's nothing but a simple async function, which is going to return hello world, and going to status 200, right? So first thing I need to do is, so I'll just show you the env list. So there are two environments already. There is binary, there is workflow. But I want to create a new environment for Node.js. And I don't recall the image name, so I'll just copy it from here. Create minus name Node.js and minus image. So now we can see the Node.js environment. So I have right now given the standard stock image that is available on the Fission. You can create any image. You can create your own image with all your runtime dependencies built into it, and then that becomes your runtime environment, basically. So there's no limitation on what kind of environment you can create, right? Now let me create a function. Create, I say minus name, hello, and minus env is Node.js, and minus code is right now here in this directory. Right? Oh yeah, that's right. Cool. So we can see our hello function has been created here. But I want to show you something more interesting here. So as soon as we created the environment, what happens on the backend, right? So the Fission stores all of its system dependencies into Fission workspace or namespace, and all the functions into Fission-function namespace, right? So you can see as soon as I created the environment and the function, so of course after creating a function, you can see three pods of Node.js hyphen along unique ID running, right? So I haven't even hit the function at all, right? I am just trying to create a function. There is no execution part that I have invoked yet, right? It has already created the pool. So this is the generic pool of generic pods. There is no code put into it, right? Now let's see how this changes once we actually invoke the code, right? Now I'm going to create a root. Let me call help. So method is get. It can be post as well. And minus minus URL, I can say serverless demo because we are in serverless conference. And I think function is going to be hello. So this ties a certain endpoint from the user endpoint to a proper function, right? We still haven't invoked anything. Please note that. And so I'm going to do a listing of routes. So it just shows you the route. Now, how do I hit this, right? How do I get a hello world? And so all right. So I'm going to say curl HTTP. Oops. It was frozen again for a moment. Sorry about that. All right. So I'm going to say, so I'm going to do a time as well, so we know the latencies, right? And let me check quickly if it is the router or the URL that I have to hit. So we'll just copy this over, but also put a time before that. Oh, that's weird. Oh, we gave the path of sdemo, so no wonder it's not going to find it. There is no route by that name, right? Here you go. So as you can notice, there is 0.5 seconds, which is like a little higher, I would say. I'm sure there is some amount of network traffic and other things playing into it, right? Let's do once more. It is a lot lesser than before. At least it is not doing that, attaching the code to the environment. Now let's look at what's happening to our pods. So as you can see now, there are 1, 2, 3, 4 Node.js instances. There were 3 before, right? So the function that we invoked caused one of the pods to be taken out of the pool and then used for function execution. And we called the function execution second time, and that time this pod was not being used. So it was reused again for the same function execution. But if I fire like hundreds of functions, this is going to scale. This is going to scale suddenly. Like maybe it will create 50 pods, 60 pods, 100 pods, I don't know, right? So that's what it's doing dynamically. Now, if we wait a few more minutes, and hopefully we have that much time, it is going to kill those pods. It is going to bring it back to 3. So any pod which doesn't get used beyond certain time, it's going to kill that again. Okay? So that's the way it works. Now, I was listening to a podcast, day before yesterday, and it was about the serverless cons that happened in New York last week, I guess. And somebody asked me, what is it, that is the second order problems that you are facing with functions, right? Monitoring is one of those. For example, I don't know if anybody of you know, but a lot of people have burnt their credit card bills by invoking Lambda million of times, or getting hacked, or getting attacked, right? So if you don't have monitoring in place to keep some check, like, hey, ideally this function should create like 10 pods at a peak level, right? What if it is creating 1,000? There is something wrong, right? So unless you have monitoring in place, you won't know if something has gone wrong, right? So those kind of things are still important and required, but this is the dynamicity of the Fission. We have about 2 minutes, 30 seconds more. I won't venture into a new demo. That will be very courageous. So I'll open house for questions, and we can, of course, discuss offline if you want to discuss as well.
So there's a few proxy which will take care of the pods which get scaled inside.
Correct.
Then you are on top of that, you're creating some consumption for a pool. Fission. I'm not clear in terms of whether it calls those proxy years or it will create your own proxy, or you are doing a proxy or a proxy or what?
That's a really good question. Let me tell you that. So the generic pool that we create is a normal replica set or a deployment. So it is managed like any other deployment set. We don't manage it. Sure. So the question is, Kubernetes has kubeproxy, right? And kubeproxy routes the traffic between pods and stuff like that. So are we doing something on top of that, or are we using the same mechanism in the functions, right? So question clear? Cool. What we are doing for the generic pod is basically using the deployment or replica set, which creates and maintains that X number of pool. The moment it is taken out of that pool for a specialization, for execution, it is not part of the replica set. The traffic is still routed via, what I can say, the proxy. But in terms of managing it, it is not managed as a replica set. It is managed as a standalone pod, basically.
Simple question.
Sure.
How does the routing differ from proxy? So you had a router. So Fission brings in the router, you added a router.
Sure.
So does the router internally use a kubeproxy, or like it's another abstraction on top of it?
So it is another abstraction on top of it, actually. So internally, whatever route it exposes, router calls it, basically. So router just puts another layer on top of it.
It's nothing to do with the kubeproxy.
Yes and no, because see, eventually the pod IP or pod name, right, is going to get called. And that is what we call as Fission. Whether that pod IP or pod name maps to X pod or X machine or Y machine is none of our business. That's Kubernetes handles. So that is handled by kubeproxy. But just finding out that pod and calling it is done by a router, basically. And router is completely stateless. Like even if you, it basically doesn't store any state. And workflows are also very stateless. Like I was going to show a demo actually today of running a workflow and then killing the workflow pod completely. And then Kubernetes brings it back up and the workflow resumes from the point where it left. So it is completely stateless in that sense, the workflow as well. Unfortunately, couldn't do it.
So could be done?
Sure.
Is the router comparable to an Nginx?
Yeah, pretty much. And today I would say the router is in early states. There are additional things that will be baked into router and it will be made more advanced. People might want to use F5, people might want to use HA proxy in the ring or whatever and whatnot, right? So definitely there are things in real world which are different and I would say at varying degrees of maturity, right?
For some reason, your router is down.
Sorry, one at a time, sorry. I think it is pretty clear on the Fission website as well as on the GitHub page. Like if you look at the PR requests, the bugs and stuff, and also the Fission Slack is open. Like anybody can join the Fission Slack. And the lead developer is Som Vasani. He's from my college. You can talk to him directly. He'll guide you through any queries you have. Or if you're looking for specific features, we can take them up as well in priority, sort of. Yeah, sorry, you had a question.
As I understand it, the traffic goes via the Fission router, right?
At the moment, yes.
So that is a single point of failure right now.
But it is stateless.
It is stateless, but does it scale? Let's say there are a lot of traffic.
It does scale because it doesn't have any state. So you can put like, today you can have one pod, tomorrow you can have 10 pods in the same replica set of a router, right? So you can actually load balance between as many pods as you want the router. So router is just like any microservice which is stateless, and you scale it the way you want it, basically. We are not supporting yet. I'm saying there will be eventually something in the roadmap, but at the moment there is nothing of that sort. So we are just using router. Router is the thing that load balances traffic across things, basically. Sorry? Yeah, I mean, Fission has a component called router, and that is all open source, basically. Yeah. List of services? Yeah, sure. Yeah, I got it. And that's a very good question. So at the moment, we are not using any services. The reason for that being labeling of pods. Like we are doing labeling change, right? When we take a pod out of the pool and put it outside for execution, we are doing relabeling, basically. That doesn't reflect very fast into services. And that's where we can't hit the 100 millisecond timeline, basically. That's the reason we are not using services at the moment. There is another backend that's coming up, which is not hot, meaning you can invoke it at your own leisure. That will use services, basically. But at the moment, we're not using services. But very good observation. Any more questions? If not, thanks for listening. And I'll show my last slide. So we are in a very early stage when it comes to serverless. And if you look at the history of any industry, anything that evolves and starts is different, very different, as compared to when it reaches a maturity, right? And I would say we are at a very early stage in this phenomenon of like cloud-native computing and serverless and whatnot, right? There is tons of stuff happening. Join the party, I would say. Start contributing to open source. Start looking at open source. Definitely closed source days are over. And definitely read this article on hackernoon.com, Why the Fuss About Serverless. I would say it is one of the most influential articles I have ever read in my last few years, sort of. And thank you for listening in all the possible languages.